So since we didn't need free body diagram A and B, can you cross them out? If it was like a quiz or a test or something, would you want us to draw those as well? Or should we just do A?
You would just draw A, B. So the steps in doing a statics problem is given, find, table, determine what you want to draw a free body diagram of. And Eric, you would have just drawn one of A and B together. But I want you, it's very important that you get really comfortable doing free body diagrams. So I started out the problem saying, draw a free body diagram in A, draw one in B, draw one in A and B together. Because I want you to remember that, you know, this goes up, this goes down, this goes to the left, this goes to the right. But for this problem, by the time you finish with the table, you're only going to choose this one, and this is all you're going to draw.
Right.
Unless I say, draw all the free body diagrams, right? And I might have a quiz, draw all the free body diagrams, because I want it, quizzes are for practice. An exam, I wouldn't. I want you to figure out the most efficient way. Isadora and then Andrew.
Using this question, so if we really draw only one, can we change and overlay?
No, I would still leave all this, because this, the fact that you needed one unknown, one equation, one body is from the find. And here you needed 5 unknowns, 5 equations, 2 from this, right? So from knowing what they wanted you to find, this is what you needed. But you realize that there's a bunch of free body there's a bunch of unknowns. But let's say, you know, at this point Eric said, okay, I'm only drawing A and B. So maybe you would have left out this, and maybe you would have left out this. And then you only have 3 unknowns, 3 equations, 1 body. So you could have done that too. So either one would work. But I want you to get comfortable with, you know, writing all, what is everything present? Andrew.
How come the friction AB has one?
Okay, so it's going to the left here, right? But it's going to the right here.
Well, in the free body diagram AB.
Okay, so it's not AB, it's only B.
Okay, yeah.
Okay? So if the load is pulling the block in this direction, the motion is going this way, and the friction is in the reverse of the motion. Because the frictional force tries to prevent motion from occurring.
And is there no connection to the 500?
There is, because if you do sum of the forces in the x, which we did, it's P minus this, minus the x component of the 500.
So how do we know that P isn't a small enough value that the 500 pulls left is more force than the friction that points to the right?
Say that again? You're talking about physically what's going on. So, do you agree that sum of the forces in the y would be the best equation to do first here?
Yeah.
Right? Because this is an unknown, this is an unknown, this is an unknown, but we know this and we know the weight. So I did sum of the forces in the y first, and I was able to calculate the normal of b, right? Then, knowing that there was impending motion here, I used the friction equation next, and found the frictional force between block B and the surface is 0.2 of this. It came out to be 1150. Okay? Then I did the sum of the forces in the x to solve for what P is.
And then why he assumed equilibrium.
What?
Using the sum of forces of why he assumed.
It's all the equilibrium, because that's all we're doing in this. Yeah. I mean, statics is equilibrium. Even if you go back to AX to A and B separate, I still did static equilibrium equations. These are correct, right? It's this one that didn't work, because it was in static equilibrium. When it was in static equilibrium, I found that NAB is equal to this. Static equilibrium, I found that the frictional AB is this. This is true. It's in static equilibrium. It's not moving. This is the one, when I did my check, I found out, shoot, this thing is not, there is no impending motion. So the statics equation always works, because we're doing statics problems. But let's go back to Andrew. Did your question get answered?
No.
your question had to do with the 500 and P and the frictional force.
Yeah. So,
That's what you got.
the friction, the force of friction B given to the left, it's saying the net force of P and the from the 500 is to the right.
So, take a look at this picture. Let's think about it physically. When I pull the blocks by force P, what is trying to keep it going the other way? The 500 and the friction. Does that make sense? I'm trying to pull these two blocks to the right, and what I have to overcome is the frictional force between here and the 500. So there's a 500-pound Newton force up here, and the frictional force is here, and that P has to overcome both X components of that to be able to pull the blocks. We can talk about it after class. I'm going to go on to the next problem. Okay, so next problem. So now it's the circular one. They're giving you distances. What do you think you're going to need to do? Moment equation. So you start setting it up while I erase this board.